Assalamu alaikum and a very good morning to all of you, my dear subscribers, followers, ladies and gentlemen. In today's video, I'm going to discuss uncertain outcomes in a particular game. I'll start with the introduction of this game, but before that, let me explain some of the background. The various games that we discussed in our previous videos were of deterministic nature. They were deterministic in the sense that the outcome of any strategy profile or pair of strategies corresponding to a cell in the normal form was known with certainty. Practically, there may be a number of causes of uncertainty relating to the effects of any course of action. For example, when a firm enters a market, it is not sure what will be the profit of that particular firm, even given the strategy of a rival firm. We start with a situation to consider where the uncertainty relates to the choice of the other player's strategy. In some games, there are no Nash Equilibria at all, at least in the sense that we have discussed so far. For example, in the famous game that is known as PRS, that is paper, rock, scissors game. We will discuss that shortly. So one of the familiar games that have no Nash Equilibria at all is known as PRS, that is paper, rock, scissors game, in which there are two players and both of them simultaneously raise their hands to indicate any one of the three possible strategies, and these three possible strategies include paper, rock, and scissor. And the rule to determine the win is that paper beats rock, rock beats scissors, and scissor beats paper. So the rule, as I mentioned, is the rule for determining the winner is that paper rapes rock, rock blunts scissors, and scissors cuts paper. This game is known in normal form. This game is shown in normal form in the following table on the next slide. So here is the form of the game. There are nine cells in this box, and this is the normal form of the game. If we look at the diagonal entries, there are zero payoffs along the diagonal, which shows that if the players adapt the same strategy, then no payoffs are made. And this, if you look at this table, if both the players show paper, then there are zero payoffs for both the players. If both the players show rock, then again there are zero payoffs for both the players. And in case of scissor, both of the players, if they show scissor, then again no payoffs are no payments are made. In other cases, the payoffs indicate that $1 will be paid by a loser to the winner under the usual hierarchy, as we mentioned earlier, that rock breaks scissors, scissors cut paper, and paper covers or rapes rock. As anyone who might have played this game, and as the underlining procedure shows, none of the 9 boxes represents a Nash Equilibria. So in this famous paper, rock, scissors game, there is no Nash Equilibria at all. Any strategy pair is unstable because it offers at least one of the players an incentive to deviate. And we may take an example. Let us suppose both the players show scissors. So we are in the last cell. Both the players, that is player A and player B show scissors. So there are zero payoffs. So it provides an incentive for either player 1 or player 2 to choose rock. In this case, when the first player shows paper and the second player shows rock, then there is an incentive for player 2 to choose scissors. So none of the boxes in this particular payoff matrix is stable and there is at least an incentive for one of the players to deviate. In order to see where there is a no Nash equilibrium here, consider what happens when player A plays paper. Player B is then best off playing scissors, but then player A is better off playing rock. So none of this strategy is stable, and there is an incentive for either player A or player B to deviate. A similar situation occurs when with any choice of strategy. So it means that in this case there is no Nash equilibrium at all. This game involves three strategies for each player. The underlying procedure shows that it has no Nash equilibrium in pure strategies. So when the strategies are pure, Nash equilibrium is not possible in this famous PRS game. The game does have a Nash equilibrium, not any of the 9 boxes in the figure, but in mixed strategies that we can show in a separate video. We'll do that in some other video later on. Here is a question for you. Does any player have a dominant strategy in the PRS game? Why is paper scissors not a Nash equilibrium? You may write your answer below in the comment section if you know, and you may answer this question. So the answer may be written in the comment section below this video. Thanks for watching this video. If you haven't yet subscribed to the channel, kindly do subscribe the channel and don't forget to click on the bell icon so that you can get notifications about my new videos that will be uploaded for you. Thanks for watching this video. Kindly subscribe this channel and share its various videos with your friends, colleagues and students.